So, welcome back. So, the ratios. Let's draw a triangle for ourselves. Here's a right angle triangle. And let's give this right angle triangle 3 sides. 3, 4, and 5. Okay, so in order to use the ratios, we need to identify an angle. So there are 2 different angles in this I could use. I could use this angle, let's call it A, or I could use this angle, I could call it B. I won't use the right angle for particular reasons that won't become obvious to you until maybe a bit later in your journey through trigonometry. But we always tend to use the other 2 angles and never really talk about this one because it's 90, and 90 has a special place in trigonometry as a degree. So the sine, which is written as sin but pronounced with a silent E at the end, sine, okay? The sine of the angle at A will always be equal to what is the side opposite over what is the longest side, which they call the hypotenuse. So opposite over hypotenuse. So I just need to know what those 2 lengths are and I'll get a fraction. So the length opposite is 4 and the hypotenuse is 5. So the sine of the angle at A is 4 over 5. And that will be your answer. Never give it as a decimal, just keep it as a fraction. Similarly, the cosine, shortened to cos, but there's an I-N-E there. Okay, the cosine of the angle at A is the side that's adjacent to A. So if 4 is opposite, 3 must be adjacent. ADJACENT over, again, the hypotenuse, which is going to be the longest side, which is always going to be opposite the right angle. Okay, and in this case, it's going to be 3 out of 5, 3 over 5. And finally, to find the tangent or the tan of A, it's going to be the opposite side over the adjacent side. So in this case, it's going to be 4 over 3. So the sine of A is 4 over 5, the cos of A is 3 over 5, and the tan of A is 4 over 3. Now, let's say I'm looking at it from B though. Looking at it from B. So I move from A to B. Let's see how this changes. The sine of B will also be opposite over hypotenuse, but opposite B now is 3. The hypotenuse is still 5. The cosine of B, cosine is adjacent. So what's now adjacent to B? It's not 3, because that's opposite. It's 4. So it's going to be 4 over the hypotenuse, which is 5. And the tan is going to be what's opposite over what's adjacent. So you can see they just change slightly around because you're looking at them from a different orientation. The only thing that remains the same no matter what angle you use is the hypotenuse will always be the same number. Okay? So that's how you get the sine, get the cos, or get the tan. If you want to find the angle though, you have to use your calculator. So I will show you on the calculator. Let's take the sine of A. If I know the sine of A is equal to 4 over 5, in order to find the angle A, I use this button on the calculator, the sign with a little -1. It's called the sine inverse button of 4 over 5. So I'll show you how to do that. Okay, press shift and then press the sine button, press a fraction, press 4 over 5. You don't have to close the fraction or the bracket if you don't, but you can, and it will give you a decimal answer because a lot of these are going to be decimal answers, but that's fine. They'll usually tell you to round it to the nearest 2 decimals, 3 decimals, whatever. Okay, there are particular fractions you'll put in that'll give whole number answers, and we'll go through a few of them in a minute, but mostly they'll give a decimal answer, which is okay. So if that was the case, I could put that in, sine of that answer, and get back 4 over 5. So it works both ways. I can put the sine of the angle in and get the fraction out or decimal, and I can put it the decimal or fraction and get the sine of the angle out. Okay, so that's the basic for using sine, cos, and tan. So let's see how it's used in the real world. That'll be in the next video.